Pocho Salcedo. Greetings to our viewers, content distributors, TV stations in Latin America, and those tuning in from coast to coast across the continental United States and Hawaii. Here in New York, we are ready to decode the stories that shape our world. This is not just the news, this is the DNA of the news. 786 days traveling in space, 7.9 billion kilometers traveled, 280 gigabytes of data collected, and more than 100,000 images taken. That is part of the story of the Rosetta Mission of the European Space Agency, ESA, whose mission was then to reach Comet 67P and drop a probe on its surface. The endeavor had the general purpose of understanding not only comets, but also the universe's origin. Among questions in the minds of scientists on the mission was whether the water on planet Earth came from a comet making rounds in the universe. To unpack all of this, we have a member of that mission who joins us from Madrid, Spain, Dr. Sebastién Besse. This is the first time I have introduced someone with an asteroid named after him. Welcome to the DNA of the news.
Thank you very much for having me today.
Dr. Sebastién Besse is a geologist and planetary scientist at the European Space Agency. Since 2015, he has been working in the Science and Operations Department in Madrid, Spain, supporting scientific operations of the BP Colombo mission, which is scheduled to investigate the surface and environment of Mercury in 2027. Dr. Besse received his PhD in astronomy from Aix-Marseille University in France in 2009. Throughout his master's, PhD, and postdoctoral experiences, Dr. Besse gained extensive experience in space exploration by participating in several space missions. He was involved in the SMART 1, Deep Impact Extended Investigation, Rosetta, and Chandrayaan-1 missions, which explored the Moon, comets, and asteroids.
Dr. Besse, the Rosetta Mission was named after the Rosetta Stone, symbolizing the decoding of an ancient mystery or mysteries. How did this symbolism align with the mission's goals of understanding the solar system and its origins?
Well, that's a really good question. And the analogy is quite clear here, is that there is the beliefs that comets hold some really important keys in understanding the solar system. Those comets have been really far away from the sun during years and years and years, and therefore they have preserved some of the information which will be very helpful to understand the formation and the origin of the solar system. So that at the beginning, when they started to think about the project itself rapidly, the names went really clear that they had to name this mission Rosetta, because the idea was to really understand the keys in understanding the solar systems.
Well, thank you. Why was Comet 67P chosen as the target for this mission, and what made it a compelling object to study?
Well, that also is like quite a story by itself. It's like it was not meant to be the original comet here. The problem is that the launcher in Europe that we use, the Ariane rocket, in that case, the first Ariane 5 actually launch failed in 2002, I believe. And therefore, it was not ready to actually launch the spacecraft and the mission Rosetta itself. But then comets move in the solar system, in the universe, they move. And therefore, if you miss your launch, then you miss your target. And then it was a bit too late to actually catch up with this target again. So the scientific community and the project, they met and they looked at it. They analyzed a lot of different data to just like, okay, we need another comet. There was some various needs in visiting that comet, not too big, not too small, that was reachable by the spacecraft during a certain amount of time. And then after this analysis, they decided to pick that Comet 67P Churyumov-Gerasimenko that was meeting the necessary criteria for the spacecraft to actually arrive at the comet itself.
Well, thank you. And what were the critical scientific questions the Rosetta mission aimed to answer about comets? And you just mentioned the early solar system.
Yeah, so the mission itself was very, very ambitious, extremely ambitious. And the idea was to bring a lot of different instruments to the comets to try to gather as much information as we can. We had previous missions visiting Comet. One of the early one was also done by the European Space Agency, the Giotto mission that visited the famous comet Halley in 1981. So in that case, we wanted to bring a lot of different instruments, get closer to the comet, get on the surface of the comet to understand actually the materials that was here. And one of the key elements that we're trying to look at here, I would not say that we were looking for the origin of life. The instruments were not necessarily designed for that. It's something quite complicated to do. But at least here, the idea was really to understand the role of the water ice that you have on comets and what's the composition of this water ice, what we have around it, and could these comets bring life on Earth? This has been some theory in the past already.
Well, you mentioned the study of the water, and there was always a belief that comets were precursors of the oceans here on planet Earth. What was the outcome of that mission? What was your understanding, if that was indeed the case or if it wasn't?
Comets' water has some specific signatures, and you can measure how the water is different than the water you have on Earth, the water you have on Mars, the water you have on Venus. We've done some measurements on all of those objects in the solar system, and we see variabilities in the type of water that we have. This is specifically the hydrogen to deuterium ratio that we're looking at. And we had very few measurements of comets for these elements. And so that was one of the key part of the Rosetta mission, was to have the instruments that will measure this. Where the deuterium to hydrogen ratio close to the Earth values, that could be a sign that actually the water on the comet is the same as the water on Earth. So maybe the comets brought the water on Earth. We did these measurements, and we didn't find exactly the same value as the one on Earth. This was different. Scientists comes to the conclusions that, well, that water is not 100% the water we have on Earth. There are other comets where we find values which are a bit closer to the one we have on Earth. So there's still a bit of a debate, and not necessarily that comets brought all the water to Earth, but significantly amount of water, maybe. And this is what we're trying to still understand here. But definitely not all the water come from the comets, and necessarily not from 67P Churyumov-Gerasimenko.
No, thank you very much. How interesting. The Rosetta mission, as you indicated, started not when it was supposed to start for reasons beyond what you were prepared to do. And I'm sure the mission faced also other challenges, from navigating into deep space, landing on a comet. What were the most difficult moments during the mission, and how did the team overcome those moments?
Maybe all of them were challenging to some level. Changing, I mean, you have to realize that there was also, together with the Rosetta spacecraft, you had the Philae lander, this small box that were to land on the comet, was designed to land on a specific comet. Just changing the comets already was just like a massive challenge for all of them. Are we going to be able to land as we were desiring it? One of the that will sound a bit surprising maybe for the audience and for everybody, but one of the moments that I know was the most challenging and maybe the most scary part is that the spacecraft was going so deep into space that there was a moment we had to turn off everything, completely turn off the spacecraft for 2 years, and had to wait that the wake-up call automatically after 2 years worked perfectly, and it did. But I can assure you that everybody was just like really stressed of that moment. That was quite a challenge here. The other big part of the challenge, at least to me, being a planetary scientist, I can see the challenges more complicated in what my colleagues are doing in helping us here, was to actually arrive at the comet and start to orbit the comet. You have to realize that you're driving somewhere and you actually don't know where you're driving. You know the directions, you know the endpoints, but you have no clue how it looks like. Imagine you're going to the beach and you don't know if you're going to have a parking space or not. That's basically a bit of how we ended up here. Luckily, the engineers and all our colleagues in Germany at ESA, which are taking care of that, they did a really good job in making sure that we got into orbit of the comet. But everybody was quite stressed about this. This was something really, really new to do.
Well, thank you very much. So, such a behind the scenes that we don't hear about it. But you mentioned the Philae lander. That was a dramatic landing because it bounced multiple times before settling. What were the thoughts of the team during that moment, and how did it impact the mission at large?
Well, the mission was like two parts, one orbiter, one lander. It is absolutely not a secret that most of the science were to be done with the orbiter itself, because he was meant to spend several months, years around the comets, where for the lander, we knew we had limited lifetime anyway. But here, the bouncing itself, nobody really detected it at first. And I remember exactly, it's like here in my head of what happens that day, where you see some of the boxes turning greens. Yeah, we got a touchdown, we got everything. You see green, 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 but you see few things are just like, whoa, that's a bit weirdish here. What's happening? What's going on? And so there was a really specific atmosphere in getting into this landing. Luckily, we ended up in a safe place, because that was really, really, really tricky. We could have actually escaped completely the comet and then lose it. And I remember going back home and in the morning seeing the pictures, like, wow, great, we made it. That was quite a moment here.
I bet. And also, the Rosetta mission revealed that Comet 65P had what you guys called a rubber ducky shape and a strange structure. What was the significance of this discovery, and what did it tell about the comet's formation?
That's the rubber duck here. You have it. Well, rapidly, I mean, a lot of people just like starting to speculate on what that mean itself, and a big part of it is like whether it is like two objects that actually collide together and stick together and form that shape. We think we have, at least I'm part of that side. There are, scientists, we always have like different opinions. I'm part of the team, and I think it's a majority that it shows that this is not two bodies colliding together, but there is maybe an erosion in the middle. It tells you that this is like, you should expect everything you can. The shape could be very different, but it's actually, for us, it's really a treasure to have this shape, because it creates a lot of unexpected situations where, for instance, the sun, you will have like shadows on the surface of the comet. Usually, when you have an object like a comet, roundish, you will not have really shadows. There will be day or night. Here we have shadows. It creates a lot of interesting processes with the water ice, where you see the water sublimating, condensating again on the surface. And also imagine yourself driving along the highway, and you go through these places where you have some rocks on the sides. What that means for the comet is like, basically you can see a bit of the interior of the comet. You have like sort of a fresh cut inside, and you can see a bit of the structure inside. So it helps you, although you have no instruments designed for this, it helps you a bit to look at how does it look like inside? How do we have stratified layers? What it looks like? And then we had some good answers on that, showing that comet, at least the big part of the comet, is probably formed by itself and has a lot of structure, like a bit like an onion ring. So that was quite unexpected. Got a good press out of the rubber duck, definitely, but scientifically it was quite helpful as well.
Interesting. Yeah, it does show an image of what the comet looked like. It showed collapsing cliffs, and also understand moving boulders. There was really a lot of dynamic movement in the nature of that comet.
Absolutely. And this was, in fact, the main point of that mission itself. A lot of past missions going to comets were just doing a flyby of the comet. So you just intersect, you calculate exactly the intersection of your spacecraft with the comet, you take some measurements, and it's gone. It takes like some hours and it's finished. Here, the case was to orbit the comet, because from the previous analysis and the previous mission, we knew there was changes on the comet. We were expecting that scientifically. We had some indications, but here we could actually stay and stare and look at it and see those changings. Cliff collapsing completely, exposing ices on the surface, seeing the jets of gas going out of the comet at that moment, seeing, as you stated, those big boulders actually moving. We don't really have a movie, as people might expect, of this boulder rolling away, but we have a sequence of images that shows you how those things are moving. And they're quite important because they really tell you a lot about the nature of the comet itself, what kind of material it is, what is the strength. It explains you a lot of the physics and the origin of the comets themselves. So that was like quite something to be able to track those elements moving on the comet.
Thank you very much. We have come to the end of this first segment. We'll be right back. And we're back with Dr. Sebastién Besse. He joins us all the way from Madrid, Spain. And we've been just exploring the general overview of the Rosetta mission. You mentioned very quickly in our first segment about this hibernation that took place for years. Just curious if you could just mention why it had to happen that way, and that was something that you had forecast before having the probe out in space.
So it was all scheduled. It was all meant to be like this. As we've discussed before, the idea was to see how this orbit the comet and see how it changed through times. And if you want to see how it changed, you have to catch the comet when it's further away from the sun, so that as you get closer to the sun, the activity on the comet will raise, and then you will be able to see those changes. But then going to catch a comet far away from the sun, you don't have a lot of sun on your solar panel, and therefore you don't have really a lot of energy to maintain all your system alive. And so it was completely designed, completely prepared that you had to do through this hibernation to be able to go as far possible to catch the comet and see how this activity was raising. It was quite a challenge, but we did it correctly.
That's terrific. The Rosetta mission has been described as a cornerstone of cometary science. And how has it influenced our understanding of the solar system, the origins of life, and where are we? What's our next step in exploration?
Yeah, well, it changed our view because it really showed how we knew little about comets. Many of our ideas were correct in the concept itself, but it went into the details of comets are pristine, they preserve some materials. But the type of comet we've been looking at so far, which are comets orbiting around the sun with the furthest away point close to Jupiter, they also evolve quite a lot. They really are under the influence of the sun in a constant way. So then it sparked interest in the community, which already had that before. But then once you've done the Rosetta mission, you start to say, okay, how do we go forward from that? There is a mission in preparation currently at the European Space Agency, which is called Comet Interceptor. And the idea is to catch one of these really long-term comets orbiting the suns around like thousands of years. And here you cannot really orbit that comet. You're going to really do just on your flyby, but those comets will be even more pristine. So here we will have access to materials which really is really close to the compositions of when the solar system started. And there are other group of scientists responding to NASA, to ESA, to JAXA, to other space agency about the idea of the next steps will probably be to get a sample from the comets here. There are two types of things you can do. You can grab the samples and bring it back home, but here you will lose all your gases, all your volatiles. And so there is a big development under the cryogenic sample return, which is you take a sample from the comet, you have the ice, and then you really understand the origin of the solar system here. So that's where we're going, but the Comet Interceptor is in preparation already on our side here.
Oh, perfect. Thank you very much for that clarification. So you receive a great amount of data, and it's still being analyzed. Are there any other questions or discoveries that remain to be explored out of this mission?
I guess so. I hope so. And I think so. I'm participating to that with some of my colleagues. This is something that also is probably not clear for everybody here. It's like during the 2 years mostly of the orbiter around the comets, the amount of data we received was really a lot. And at the same time that you're trying your best to monitor the comet, to acquire the data you want, you have to analyze at the same time. And we're all the same. We're all human beings. At some point, we have to sleep. We don't have time to look at everything we want. So it takes years to keep analyzing the data. You will be really amazed to see how many scientific publications every year are still coming from the Rosetta data. So there is like a lot to look at. I can't really tell you what we're going to find because that's the baseline of the science here. But everybody can actually get access to those data. You go to these archives, which the space agencies are holding, and you can have yourself access to those data and do your own analysis if you want. So don't hesitate and help us, because this is really a too big endeavor for all of us.
Extraordinary. If you could revisit the Rosetta mission, is there anything you would have done differently, or any additional questions you wish the mission could have answered?
Well, we would have really, really loved, many of us, that we go for another circle around the sun. So imagine we catch the comet when she was the furthest away from the sun. We accompany the comet when it gets close to the sun and a bit on the departure. And at some point, we had to stop because we didn't have enough energy to maintain the spacecraft. The same reasons why we went into hibernation the first time. What I would have loved is that we do a second hibernation and then we do another round around the sun, because here we would have been able to really further understand the change from one point to one point. Because what we've seen is the comet at the moment, how it changed. I really would like to see how it changed the second time. That would have been something really difficult to do. This was actually not even possible to do from the spacecraft point of view. But, with some of my friends, we were wondering as well if we still had the energy to go for another 2 years of science exploration of the comet. We were exhausted, all of us.
Sebastián, what first sparked your interest in the space exploration, and how did that passion evolve into your involvement with the Rosetta mission? As a matter of fact, an asteroid was named after you. Please tell us a little bit about that journey.
That journey is a specific journey, like probably a lot of people. My background has been, I've been always interested in geology, in Earth, in rocks, in those kind of things. I've looked into it, and as often, this is a matter of meeting some people. And some people told me, hey, well, if we have also rocks elsewhere than Earth. I started to look into this, and what really helped me is I got access to people that were really nice, really helpful, and I rapidly realized that during the university itself, I could contribute to those missions for real. I mean, my first mission that I worked on was the Smart One mission that went to observe the moon, and understanding, during your studies that you can participate to this really started to really excite me a lot. And I continued, and I've been lucky to be part of an era where there are still a lot of projects. There are still going on projects nowadays as well. And so my advice to everybody is, like, if that's your interest, just go grab the right persons. They will be helpful. They will try to get you involved in those projects.
One of the projects that I understand you're working currently is the Bepi Colombo mission, if I pronounce correctly. Tell us, what is that mission all about, and what is your role, and how far into are we in this project?
So the Bepi Colombo mission is a mission going to orbit around Mercury. So this is quite a stretch. We go from the comet, which are the most pristine, faraway objects from the sun, to the closest one from the sun, Mercury. But it's also a very important mission that helps us to understand Mercury itself, which is as the closest, you need to understand the furthest and the closest object here. Bepi Colombo was launched in 2018. Still not arrived. It's a long journey to go to Mercury, because you have the sun next door. You don't want to end up in the sun. You want to go to Mercury, so you have to take your time. We're going to arrive there around the end of 2026. We will start our science observations for probably 2 years around Mercury, starting in 2027. My role in that project, I'm a scientist here, and I'm dealing with the strategy of the operations, trying to make sure that our scientists, colleagues, which are in different universities in Europe, get the best that they need from that missions, that they get exactly the scientific observation they need to understand the mysteries of Mercury.
Would you be kind enough to tell us a little bit about the collaboration that goes on among scientists from Europe, NASA programs here, programs in Asia and Europe and China? How does that collaboration work?
Works very well. There is quite a lot of different projects in good collaborations. Bepi Colombo, for instance, is a really big missions in collaboration with the Japanese space exploration program. Beacon with 2 spacecraft, one from Europe, one from Japan, both working together, going to Mercury together, and comparing their scientific data. We have regular exchange with our Japanese colleague to make sure the progress of the missions. And when we will be the science phase of the missions, we will exchange between the scientists to compare our results and actually combine our results together. Rosetta itself, for instance, was also a good collaboration between numerous countries in Europe and also collaborations with the Americans. The NASA was actually a big partner, had instruments dedicated to observe the comet with NASA. So the same way, you exchange with your counterpart on the NASA side, making sure everything goes in the right directions.
Just about in closing, we have a couple of minutes. What you wish you knew at the beginning of your involvement in space exploration and geology and the studies that you know now that you wish you knew at the beginning of your journeys that would have made your life a lot easier and you had a better understanding?
Well, one thing, and I think that's exactly what your program is contributing to, is to know that it's feasible, to know that it exists. Actually, that was actually something not really easy when I did my university in the 20 years ago. There was not as much media as today, and knowing that there is a space exploration, that was like not something really accessible and easy to understand. I was lucky, as I mentioned, to find right people that brought me into that directions. But this is something that hopefully for this generation today is easier, that there is opportunities, there are access to those programs, and you can get into it. The things I would have also really loved to learn is that to do a space missions going to a comet, to Mercury, to whatever, you need a lot of different people. And almost all of the backgrounds are necessary here. My background is in geology. You have astrophysicists, you have mathematicians, you have a lot of people in this industry that helps us all together to get to the targets that we want to go. That's something I did not capture very well in the past. I thought a mission exploring the comets would be just only scientists. Actually, scientists probably the smallest number of people on that project. So this was something that I discovered, and this is really important. It's like there is room for a lot of different profile and different expertise which are needed on those projects.
Well, thank you very much. And in conclusion, what is the one thing that you wish as an audience we can really remember when we think about comets, when we think about space exploration?
That before we even knew we could do it, we told ourselves we will land on a comet. We've never done that. Nobody had done it before. We didn't know how to do it. And we just didn't care to some extent, which is we're going to work all together and we're going to do it. And actually we did it.
Oh, that's a lesson that could be applied in every area of our lives. So we met Dr. Sebastién Besse, and it has been an honor, a pleasure to have this dialogue with you. I hope you come back to the program sometime soon. Thank you very much.
Thank you very much. I'll come back in 2 years when we arrive in Mercury.
Thank you.
Thank you.